Let's talk about sine of x first. Let's set up a table. Okay, let's start with 0. If x is 0, what's sine of 0 going to be?
It would be 0/1, which is 0.
0, yeah. Okay, so we can plot the point 0, 0 on the sine graph. Let's do pi over 2. You know what sine of pi over 2 is equal to?
So it'd be the hypotenuse is always 1, right?
Yeah, that one's 1, right? Opposite and the hypotenuse match, so it's 1 over 1.
Yeah.
Okay, let's put that here. Okay, let's do pi. What's sine of pi going to equal?
So that would be 0 again.
Yeah, let's do 3 pi over 2.
That would be 270, right?
Yeah,
So we get that line. Yeah. That would just be, that'd be -1.
yeah. Okay, put that here. And then let's do 2 pi. What would that be?
Back to 0, I think.
Yeah. Okay. After that, once you complete the revolution, it'll
It
repeat
should just
itself.
go. Yeah.
Yes. So this is what the sine graph looks like. Anything, and 1 and -1, the max, right? Because every other angle, the opposite side is always smaller than the hypotenuse. So that's why in between it's always going to be lower than 1 and -1. Does that make
Yeah.
sense? Okay. So notice that this would be one full cycle of sine, right?
Yeah.
The period for sine is 2 pi. This is how I remember it. You can think of it sine starting at the middle, and then one period of it will end in the middle. So middle to middle. Because cosine will look similar, but it's just shifted over a bit. We'll get to that later. Okay. So now let's talk about cosecant. So cosecant is the reciprocal of sine. So cosecant is equal to 1 over sine of x, or you can think of it as hypotenuse over it opposite.
Yeah. That would, this one have the asymptotes again, right?
Yeah, exactly. Because
Instead of having like 0, you'd have undefined because it would be switched.
yeah, exactly. Instead of 0 over 1 becomes 1 over 0. So cosecant's going to have asymptotes here, here, and here. So all the intercepts. Okay. The reciprocal of 1 is still 1, right?
Yeah.
So it's still going to be 1 here and here. Cosecant's going to have these points. But the thing with reciprocals is that small numbers become big numbers, right?
Yeah.
Like, for example, 1 over 10 becomes 10 over 1, right? So if you have a small number, that becomes a big number. So then essentially all the small numbers become big. What you can think of
Yeah.
what happens as, go
Would it
ahead.
like flip?
Yeah, exactly. It flips over, but becomes kind of parabolas in between. And then you have negative parabolas here. This would still be in the same count as being the same cycle because it hasn't repeated itself. It's not the same thing.
Okay.
The period would still be 2 pi in this case. Because then after the negative, then you go back to the positive parabola and then a negative parabola. So that's when it repeats itself.
Okay.
Does that make sense?
Makes sense. Yeah. Yeah.
So these are called reciprocal trig functions. So cosecant's reciprocal, cotangent's reciprocal. And the way to remember is that every pair has one that has a co in front of it. So sine and cosecant are the reciprocals of each other. Only one has co in it. Tangent and cotangent, only one has co in it. And then the other one, cosine and secant. So cosine is the one that has co in front of it. And then secant's the reciprocal of cosine. If you go back to the picture, yeah, which one would you say is the cosecant graph?
Should be D.
Yeah, exactly. Right. Should be an asymptote at the origin, and then it alternates U's. Okay. Okay, this one. Okay, so cosine x start at 0. Do you know what the cosine of 0 is?
Cosine is adjacent over hypotenuse, which would be in this case 1/1.
Yeah, good. Notice that cosine starts at the top of its curve. Okay, what about pi over 2?
That one would be 0.
Okay, yeah, because there's no adjacent side, no base. So 0 over 1. So that we can mark here. Okay, what about pi?
That should be -1.
Yeah, right. Adjacent side's negative. Mark that here. And then what about 3 pi over 2?
That one would be
And then what about 2 pi?
that would go back to being 1.
Yeah, good. Okay, so now you see that how cosine, it goes from top to top as one period.
Yeah.
So it's the same exact shape as the sine curve. It's just shifted over where it starts at the top and then the first period ends at the top. That makes sense. And then secant is going to be essentially the same idea as cosecant. The asymptotes would occur at the intercepts. And then secant is just the same shape, except it's also shifted over where the vertex of the first parabola is at 0 instead of this asymptote being at 0. That makes sense. Secant equals 1 over cosine, which is also equal to hypotenuse over adjacent. Yeah, typically when graphing cosecant and secant, you want to draw the sine and cosine graphs first, and then you can draw the secant and cosecant based on those.
Okay.
Okay, so now answer this question. What's the domain of cosine x?
It's a domain. Can X be all real numbers?
Yeah, exactly. You can plug in any value angle into cosine, right?
Yeah. Y would be like between 1 and -1, but
Yeah,
domain is
exactly.
just all.
Okay, let's do the last one, which is tangent x. Okay, let's start with 0. So what is the tangent of 0 degrees?
That one would be 0.
Yeah, good. 0, opposite is 0. Okay, so we have a point at the origin. Let's do pi over 4. What's the tangent of pi over 4?
I think that should be 1.
Yeah. 45, 45, 90 triangle is
Yeah.
opposite adjacent 1. Okay, so we can mark that like here. Let's do pi over 2. What's the tangent of that?
That'd be undefined.
Yeah. It will be opposite of 1 over adjacent of 0. So then we can mark an asymptote here at pi over 2. Okay, and then let's go backwards. 1. What's negative pi over 4? Do you know how negative angles work?
Negatives are just going clockwise instead of counterclockwise.
Yeah, exactly right. So where would negative pi over 4 be?
I'd be in the fourth quadrant.
Yeah, okay. And what would the tangent of that be?
It'd be
Oh,
negative.
Okay, -1. Then we can mark that point here. And then same thing. What about negative pi over 2? Undefined, right? There's going to be an asymptote there. Okay, good. Yeah. And then from here, you can draw the curve through the points and then just follow the asymptotes. So that's what tangent's going to look like. And then it's going to, just like cotangent, is going to repeat itself. So notice that in this case, tangent is increasing, right, as you go left to right.
Oh, yeah.
And then notice that at the origin is the center of one of the curves rather than it's starting with an asymptote, like cotangent. But then notice, what's the period for tangent?
That'd be pi.
Yeah, good. It's still pi because that's the curve repeat itself every pi units. Okay, so how would you answer this question?
The question was asking for the range, right?
Yeah.
Would it be all numbers or all real numbers since it never hits the asymptote, so it'll just keep increasing or decreasing?
Yeah. It's going to cover all y values because it goes up forever and down forever without any
Yeah.
breaks. Okay.
Interesting, yeah. Does make sense though.
Let's draw two sets of axes. We can just directly talk about cotangent. Yeah, okay. Okay, so let's do a quick table of cotangent function. Let's start with cotangent of 0. So we have a 0-degree angle here. Do you know what sides cotangent goes with? Tangent is the reciprocal of tangent. So it's the flipped version of tangent.
Would it be adjacent over opposite?
Yeah, exactly. You can think of it as 1 over tangent x, which is going to equal adjacent over opposite. If we look at 0, what's the adjacent side and what's the opposite side?
The adjacent would be 1, and then the opposite would be 0.
Right.
So it would be undefined.
Yeah, exactly. So at 0,
I think.
cotangent is not defined, which means that we have to put an asymptote there. Okay, let's do pi over 2 real quick. So now that's 90 degrees, which is a vertical line. What's the adjacent? What's the opposite for 90 degrees or pi over 2? Remember, adjacent goes with the base of the triangle, opposite goes with the height. In this case, a vertical line has a base of 0, right?
So adjacent would be 0.
Right. And 0 over
It's just
1.
the base.
Right. So
So
cotangent.
the thumb would just be 0.
Right.
Yeah.
So for cotangent, we'd have a point at pi over 2, 0. Draw that here.
That makes sense.
Okay, let's do pi over 4 real quick. Before that, do you remember what angle, how many degrees is pi over 4?
So, well, that's 45, right?
Yeah. So then what's adjacent over opposite? What's cotangent of pi over 4? 1 over 1, right. Pi over 4 is 1, so pi over 4 is about here. You get a point up here. Let's call that 1. And then let's do 3 pi over 4. Would you know what quadrant 3 pi over 4 is going to be in?
That would be the second quadrant.
Yeah. And the reference angle, do you know what the reference angle is?
So it'd be, would that be 45?
Yeah. You have another 45, 45, 90 in the second quadrant. So what would the cotangent of that be in the second quadrant?
Wouldn't that also be 1? Or no, it would be -1 because it's only because the opposite's still positive.
Yeah, good. Okay. So then we can draw a point here. Okay, and then let's just do pi. So what happens? So pi is 180. What happens if you get to pi? What's the cotangent of that?
Would it just be undefined again?
Yeah, it'd be -1 over 0, right? So undefined.
Yeah.
So then we draw another asymptote at pi.
Interesting.
Okay. So then between the two asymptotes, so then we have enough, we can just draw the curve through the, what's going to happen is that it's going to follow the asymptotes. So it's going to look something like this, and then look something like this.
Oh, interesting.
Okay, so that's what cotangent looks like. And then once you get to the third quadrant, it repeats itself. If we continue this, what's going to happen is that it's going to repeat itself because in the third quadrant, both opposite and adjacent sides are negative, right? So it's going to be positive overall. So then the curve's going to repeat itself. And then there's going to be another asymptote at 2 pi.
Interesting.
And then it's going to repeat itself beforehand. And if you go the other way, it will also repeat itself like this. Does that make sense?
Yeah.
Yeah, because the angles essentially, the ratios kind of repeat themselves, right? If you're in the third quadrant, all your values are going to be positive, just like the first, and then the value is going to be the same as in the first quadrant. So that's why it repeats itself here.
Yeah.
And then when you're in the fourth quadrant, the value is going to be negative. So it's going to be the same as if you were in the second quadrant. So then it'll be negative down here. And then once you get past the first revolution, then it's just going to be the same over and over. Then you're ending up plugging in coterminal angles. Okay, so do you know what the period means?
Is that like I'm just gonna take a guess. Is that the like distance between when it repeats?
Yeah, exactly. It's kind of like how long a cycle is, how long it takes for it to repeat itself. So what would period be in this case?
Would it be pi over 2? Since it's like every quadrant it'll repeat.
Well, if you go from 0 to pi over 2, it's still,
Oh yeah. Wait, would it just be pi then?
yeah, if you
Since that's
pi,
what
because every one of these is a cycle.
oh yeah, every 2 quadrants. That makes sense.
Yeah.
Yeah.
Okay, so that's what period is for this.